Okay, guys, so this is part two. Hopefully, you watched all of part one, got that done, and we're continuing to talk about the spring tides and the neap tides. Here we have an animation that is a really good one. It shows not only the moon phases, but as the moon is going to revolve around the earth, it's going to show how the tides work. So, we're going to start our animation. Down here, we have a graph showing the height of the tides, that's the height of the tide, and then the time during a day. So we're going to start, this is a day and time. So every time you see one up and another up, that's going to be a 12-hour period from one up to the next up. Because remember, we have two high tides and two low tides every day. And as you notice, as we go across, now we're getting into the full moon. So here we have a full moon. You'll notice over here, the moon and the earth and the sun are all in a line. And if you look at the height of the high tide and the height of the low tide, there's a big, huge difference from when we started, back when it was the quarter moon. We started at the first quarter. So we're going to continue on. And once we get past the full moon into the waning gibbous, you'll see the phases over here. It's going to start to get smaller again, and you're going to start to have a lower high tide and a higher than normal low tide. And it's going to continue to get a smaller difference between the two all the way to the third quarter. Now we're at the third quarter moon. Here we have the first quarter. You have a very small difference from high to low. Full moon, we see a very large high tide and a very low tide. And then the third quarter, we're back to the same as it was during the first quarter. And we can probably predict what's going to happen as it goes on around. You also see the difference in the bulge on the tide. The high tide always follows the moon and is on the opposite of the moon. But as the moon and the sun kind of join forces, you see that it does become a much higher high tide and a much lower low tide. So now we're back at the new moon. We've gone an entire month all the way around the earth, and we've seen a big shift in the high tides and the low tides.
All right, now we're now on the second glue in. Hopefully everything has dried. So this is how we would actually draw and graph the tides. Now this whole thing right here is 1 month. So from here to here, we're talking one lunar calendar. So all of the moon phases would take place within this time. So this down here are the days. And these right over here is how many feet the tides go up. So all of these top ones right here, these are my high tides, okay, at the top. And all of these down in here are my low tides. So you can see that this is from here to here. It's a pretty big difference. And so as it gets over here, it's bigger and bigger difference. This one almost goes to 4 feet, and this one is down to like -4 feet. That's a pretty big difference just by looking at this. So I know right here that this is probably either a new or a full moon. Over here, it's a small difference right here because it gets skinnier. And so this is probably one of my quarter moons. And this one over here, if I look at this tallest one right here, this one right here is a little about 4.5 feet. And this one's about right about 4 feet too. So I think this one right here is probably my new moon because here this is the largest difference between here. So this would be my new moon here. And then if I kind of work backwards, if this is my new moon, then the quarter in front of that one right there is going to be my third quarter. So third quarter. This one would be my full moon. And this one over here would be my first quarter. So just by looking at this, you can tell where your neap tides are. Remember, the neap tides are going to be where your quarter moons are working against your moon. You've got your sun your third quarter working against your sun. You've got your sun pulling in one direction and either your first or your third quarter pulling in another direction, so they kind of counteract each other. which which makes for not very large high tides and larger than normal low tides. So that makes that little pinch right there in the graph. And then over here you've got our spring tides. Our spring tides, and again, I like to think of our spring tides like just like a spring, just kind of leaps off. There are super high tides up here and super low tides. Now there is a very large difference right here between the high tide and a low tide. And so that's important to know as well. Here you've got a very small difference between your high tide and your low tide. And then of course over here, this is also a spring tide. It is your new moon when it is nice in a nice straight line. Again, another large difference between your high and low tide. Okay, now this is looking at an actual calendar view, and you can see that right here, there's a pretty small difference. It's kind of small little lines right here. So this tells me this is probably a quarter moon in here. Sorry, it keeps bringing it back up. But over here, like on the 9th, 10th, 11th, here, these are really tall high tides and really low tides right in here. So this tells me that this is more of a spring tide. So again, that one's more of a spring tide on like the 9th, 10th, 11th, one of those days. You can also see that on here, like if you look at the 10th, I don't want to go too far, but right above the 10th, right, if I hover right here, there are two highs. There's 31.87 is the high and 33.22. So there are two highs and two lows. Here's -3.75 and -1.33. So there are two highs and two lows every single day. So again, you know that this is a spring tide in here. And then it starts to kind of gradually get more of a little smaller little humps right here. So this is going to be a neap tide in here. And then again, it gets to some larger ones over here. And so you've got some more of your spring tides again right in here. So this tells me that probably this one right here is probably a new moon because it's pulling on the same side as the sun, which makes these over here, this neap tide a first quarter, and this is probably a full moon, and this is going to be the third quarter.
Okay, you guys should be done with the notes on the spring and neap tide, the graphing that we just went over with you guys. So we're going to finish with this video. We really like the animation on this video. So while we're playing the video, we may pause or mute the audio on it, and we're going to be talking a little bit.
This shows 12 hours at the famous Bay of Fundy in Nova Scotia, Canada. It's the biggest tide change in the world. But what force could move such a massive body of water? Gravity. Here's the Earth rotating on its axis every 24 hours. We'll now draw the Earth as a diagram with its surrounding layer of ocean. And to the right is the silvery moon. Everything is attracted to everything else in the universe with the force of gravity. So the moon is attracted to the Earth. And the Earth is equally attracted to the moon. Notice that the two force arrows are the same length, showing that gravitational attractions are of equal strength.
And guys, that brings us back to our forces. When we talked about balanced and unbalanced forces, these forces are equal and opposite. They're balanced, and that's why the moon doesn't crash into the Earth and we don't go flying into the moon. They're balanced. It's a balanced system.
But we're only interested in the force on the Earth here. The moon pulls on the ocean closest to it and makes it bulge outwards. When the Earth rotates, the sea level is higher at this point in its rotation, causing a high tide. And a low tide where the oceans don't bulge. So you'd expect one high tide each day.
Okay, this is definitely a misconception. We know there are 2 high tides and 2 low tides each day, and he's about to explain how that second high tide occurs on the other side of the Earth.
But here it gets interesting because there are 2 high tides a day. How come? This is because the strength of gravity is greater when objects are closer. We'll call the location of the ocean on the near side of the moon point A, at the centre of the Earth point B, and at the far side ocean point C. The strength of the moon's gravity is strongest at A because it's closest to the moon. So the part of the ocean that bulges towards the moon most is at A. But the moon's gravity also pulls on the Earth, moving it towards the moon as well. This has 2 effects. First, it makes another bulge at C. Second, it fills in the bulge at A, but not completely, because A has moved further towards the moon than B. Lastly, the far side ocean at C is also attracted to the moon, but it moves least because the moon's gravitational pull here is at its weakest, being farthest from the moon. This leaves a partial bulge at C, so not as big as the one at A.
Okay, guys, so now you can see it's high tide and we're low tide. There's the second high tide and the second low tide. That was one complete day. Now we're on the second day, a high tide and then a low tide, and then another high tide and another low tide. So this, the Earth just continues to rotate and you got high tide and low tide. Okay, guys, so that wraps up our tides lesson. Again, make sure that you have written everything that we wrote. If you need to go back, if you want to rewatch a video, you're certainly welcome to do that. And make sure you have everything written down in your journal. We want to make sure that you understand how many high tides and low tides there are a day. And then, of course, how neap tides, which are the less extreme tides, occur during the quarter moons, and the spring tides, which only occur during full and new moons, have the more extreme higher highs, and of course the lower lows. So thank you and hope you enjoyed the lesson.